this video, we will be taking a look at the dynamic analysis capability of GeoMedia. You will see how you can create nested queries where the output of one query serves as the input to another query, and all the queries can be stored and saved as a comprehensive analysis. If there is a change in the input parameters, the queries show the results dynamically. In other words, you'll see the results update live without having to rerun the queries again. The slope, aspect, and drainage network layers you will see in this demo were derived from a digital elevation model using GeoMedia tools, and they will be used in this dynamic spatial analysis. Let's get started. I've got a remote sensing satellite image and a digital elevation model. The following layers were created from the digital elevation model using GeoMedia grid analysis commands. Shaded relief to give us a better visual. Slope was analyzed and polygons were created and then classified into one of the following three categories: 0 to 10%, 10 to 20%, and 20 to 65%. Aspect was analyzed and classified into 45-degree increments. And then finally, soil polygons were created in GeoMedia to represent the soil type. The drainage network is an extraction from the digital elevation model using the GeoMedia grid analysis tools. The existing road network was overlaid on top of these layers. GeoMedia was then used to perform the following analyses. Identify landslide zones within a specified buffer zone based on the existing information layers. In order to do this, a buffer zone is created around the road features within which GeoMedia identified areas where the slope was greater than 20% and the soil type was soft. These areas could be identified as areas that are prone to landslides. As an added reference, you can also hyperlink any photographs of the area for a good visual. GeoMedia spatial relationship intersection is then used to identify the crossing of drainage and roads to identify the flood-affected zones. To summarize the benefits of what's been done, a landslide analysis was performed and the results were visualized in both a 2D and a 3D environment. The analysis is dynamic in nature, such that if any of the input parameters change, and this would include buffer zone radius, maximum slope condition, or soil type, the results would get updated dynamically without having to rerun or recreate the query and redo the analysis again. You could use the analysis when defining proposed new roads for future road planning. Landslide zones will be displayed dynamically to assist in making smarter decisions about road planning. Once I've got the analysis running, I can use it to evaluate any new roads I may want to plan in the area, and it will dynamically analyze the ground conditions. I can also toggle to 3D if I'm running the GeoMedia 3D extension and continue with my analysis in a 3D environment. I have the same capabilities in 3D that I would have in 2D, as you can see.
That concludes the demonstration today. Thanks for your time and have a great day.